Okay, so what I'd like to talk about now is I'd like to talk about the tension that is produced in a muscle fiber, so in the entire muscle. And to do that, we're going to have to talk about how frequently that muscle is being stimulated, meaning how often is that motor neuron firing? Is it firing a lot? Is it firing once? How big are the spaces between when that motor neuron is sending an action potential to the muscle cell. So we're going to start off with the base concept, which is the muscle twitch. And what a muscle twitch is it means that there is one stimulus. That means the motor neuron has an action potential reach that neuromuscular junction once. So one action potential. And that is going to cause that muscle to contract and then relax. Okay. Now let's make sure you understand what your axes are on this graph. This is time. So the farther we move to the right, the more time has passed. And this up here is muscle tension. So here, as we go higher up this line, we have more muscle tension produced. As we go lower down this line, we have less muscle tension produced. Okay? So what we're saying is that at this point in time, the motor neuron has fired. And notice we have a delay. And then after that delay, the muscle starts to contract. So we start to get tension being produced. We reach a maximum tension level for this twitch, and then the muscle begins to relax. Now, just to remind yourself of what is occurring inside the cell, here it's stimulus, and throughout this latent period, throughout this lag, we're going to have the action potential in the motor neuron, transfers action potential to the muscle cell, and then calcium begins to be released, and finally at this point we start to get our sarcomeres shortening. Okay, so there's a whole range of steps that have to occur between motor neuron firing and sarcomeres shortening, and that's why we have this latent period. Now here we've got this calcium coming into the cytoplasm. The sarcomeres shorten, shorten, shorten until they reach a maximum tension level, and then at this point the action potential in that motor neuron, it's disappeared, the sodium's been pumped back into the cleft, and at this point the calcium is starting to be pumped back into the cleft as well, or back into the sarcoplasmic reticulum as well, and so we're no longer having interaction of the filaments, and so the sarcomeres are starting to lengthen, and the muscle is starting to relax, so we get a reduction in the tension. Until finally, back around this point, everything is going to be reset. All of the calcium is back into the sarcoplasmic reticulum. All of the sarcomeres are at resting length. So this is one twitch. Okay? But let's talk about a variety of things that motor neurons can do instead, because our needs for muscle contraction may be different. Sometimes we want to sustain a contraction. We don't want to just contract and then be done. Okay. So the first thing we're going to look at is a thing called Ch10p, and this means a stair step. So each one of these is an individual twitch, and notice the green arrows in every case are stimulus. We still have our same axes, so we still have time right here, and we still have increasing tension up here. Okay? Excuse me. So we have a stimulus, a twitch, another stimulus, and notice this amount of tension looks like it's a bit higher. We have another stimulus, and notice the tension gets even higher. So with each stimulus, our tension is getting higher until we reach a maximum level. So what's going on here? Okay, let's go for a minute to our notes packets. So let's talk about what is going on with Ch10p. Okay, so with Ch10p, we're getting a stimulus. Actually, I want to make this green. So we're getting a stimulus immediately at the end of the relaxation phase. What's happening here is that not all calcium is back in the sarcoplasmic reticulum. So tension increases each time, or with each stimulus. Okay, so let's go back and look on this slide. What happens here, so we're stimulating as soon as this muscle is relaxed. So we actually can't measure any tension in that muscle, but it turns out not all of the calcium has been put back into the sarcoplasmic reticulum. So when we get our next stimulus, rather than having this much calcium and we've got to move up, we start with this much calcium. And so now we can contract even more because we start with a greater degree of calcium. And so that's happening each time until you get to a maximum level. So each stimulus, there's a little bit more calcium left in that sarcoplasm. Now let's look at what's happening here. So here we've got a stimulus, contraction, relaxation, but now we don't actually get to the end of relaxation. Not all the sarcomeres have reset before we stimulate again. And again, so now we get a higher tension. Again, we don't all the way relax until we stimulate again. So each time we get a higher and higher tension. And so this is called wave summation. So let's go back here to our notes. Okay, so with wave summation, we're getting a stimulus before the end of relaxation. Okay, so we let a little bit of relaxation happen, but we stimulate before it fully happens. Okay, so not only do we have not all of the calcium is back in the SR, but also not all sarcomeres are at resting lengths. Okay, and so tension increases with each stimulus, but even more so than in Ch10p. So if we go back over here, again, what we're seeing is we're seeing stimulus, and we have contraction, some relaxation, but not fully, before we stimulate again. So not only do we have calcium still in the sarcoplasm, but also our sarcomeres are still partially overlapped. They haven't fully relaxed. Okay, so rather than starting here, we're starting here, which allows us this time to contract even more to produce more tension. And so wave summation, with each stimulus that happens before the end of relaxation, the tension goes up each time. Now eventually, if you keep doing wave summation, you will, so here we're seeing wave summation, but eventually you will reach a maximum for that timing of stimulation, and that is called incomplete tetanus. Okay, so if we were going to put that in our notes, incomplete tetanus is going to be wave summation that reaches a maximum tension for a given frequency of stimulation. Now the final one that we want to look at is what's called complete tetanus. Now here we stimulate, we get contraction, but notice we stimulate before any relaxation happens. So it is a continuous stimulation with no relaxation. And notice here we reach a maximum tension. This is a maximum tension for that muscle. And this is called complete tetanus. So we cannot contract, we cannot produce any more tension for this muscle. Okay, so again, on our notes packets, complete tetanus is going to be stimulation without any relaxation allowed. And so this causes maximum muscle tension. Okay, and you may have heard usually at some point in your life you get a tetanus shot. It turns out that's to protect you against a tetanus toxin produced by a bacteria, and that toxin causes complete tetanus pretty much every muscle in your body. So can you imagine if every muscle in your body contracted and could not relax? And so that's why you get a tetanus shot, is to prevent that toxin from affecting you. Okay, and so I believe that those are the different types of tensions that can be produced in a muscle fiber. And here's some activities to help you get familiar with that. On the next page, we're going to talk about how a muscle uses all of these different types of stimulation to give you a contraction in that muscle.